Question. DS. Of the cars manufactured last month on a new production line, 5% were defective. Of the cars that were defective, 4 over 5 had a broken window and the rest were slightly dented. If all of the cars had a broken window or slightly dented were defective, how many of the cars manufactured last month were slightly dented? Condition 1. 400 of the cars manufactured last month on a new production line had a broken window. Condition 2. 500 of the cars manufactured last month on a new production line were defective. Solution. Now we will solve this DS question using the variable approach. DS, one variable, question. Condition 1 gives one equation. Condition 2 gives one equation. DS question with one variable. We will now solve a DS question with one variable in the original condition. Now, one variable would generally require one equation to find the value of the variable. We know that each condition should give us an equation, and each equation should be able to give us the value of the variable. So, each condition should be sufficient independently, and we should logically get an answer D. Complementary 2 by 2. This type of table has sets that are complementary to each other. They are seen quite frequently on the GMAT, and the two columns are complementary to each other, and similarly, the two rows are complementary to each other. This question is called a complementary 2 by 2 question. According to the question, complementary pairs are defective, non-defective, we will place them in columns, and broken, dented. We will place them in rows. Broken, which are defective, and which are non-defective. Dented, which are defective and non-defective. To prove this is correct, let's apply 3 steps suggested previously. Follow the first step of the variable approach by modifying and rechecking the original condition and the question. We have to find the number of cars manufactured last month on a new production line that was slightly dented. This question is currently the most frequently appearing type of question in the GMAT math section. We call this a complementary 2 by 2 question. Let's first draw a table as below. Since this question is a percentage question, we will use 100C for the total, in other words, 100%, using the IV approach. Broken windows, which are defective, is 4 over 5 times 5 times C equals 4 times C. Broken windows that are non-defective, 0. Dented, that are defective, 1 over 5 times C equals 1 times C. Dented that are non-defective, 0. Total of the defective, 100 times 5% equals 5 times C. Total of non-defective, 100 times C minus 5 times C equals 95 times C, with a total of 100C. Remember, the fact that there are zeros in the table above because of the sentence, if all of the cars that were broken or slightly dented were defective. This question looks quite complicated, but it is really very simple. Trust the variable approach and study hard. So, we need to know the value of C. Follow the second and the third step. From the original condition, we have one variable, C. To match the number of variables with the number of equations, we need one equation. Since conditions 1 and 2 will provide one equation each, D would most likely be the answer. Right, it looks complicated, but the answer is D because there is one variable. Can you feel the power of the variable approach? Recall 3 principles and choose D as the most likely answer. Let's take a look at each condition separately to prove that our answer is correct. Condition 1 tells us that 400 of the cars manufactured last month on a new production line had a broken window. Putting this into an equation, we get 4 times C equals 400, which we can rearrange to get C equals 100. The answer is unique, so the condition 1 is sufficient. Condition 2 tells us that 500 of the cars manufactured last month on a new production line were defective. Putting this into an equation, we get 5 times C equals 500, which can be rearranged to get C equals 100. The answer is unique, so the condition 2 is sufficient. Each condition alone is sufficient. In this question, the original condition gives us one variable. That's why the correct answer is D. So D is the correct answer. Answer D.